Hello interwebs, welcome to Let's Fix Computers. One of the first videos in the new shop. So background isn't very exciting at the moment. Bear with me, we're still getting stuff set up in here. So, you know, stuff in the background, the cameras and all the layout is still going to be moving around over the next, well, few months basically while I figure it all out. In the meantime, let's get started on this. This is a MacBook Air I've got here that doesn't turn on. It came in and it was very bent. This is after I've tried to give it a little bit of GBH to straighten it out. So this has been sat on or something like that. I don't know. At any rate, it doesn't turn on. I've got the battery and the keyboard disconnected at the moment, or the trackpad rather, which goes to the keyboard. So theoretically, if I plug in the charger, the laptop should switch on of its own accord. So let's plug it in and we'll see what it does. I'll just open the lid. And we've got a green light on the charger. But no power, nothing is happening. So, alright, so why does this not turn on? Let's see if we can figure it out. I'll close the lid again. And what we're going to do our basic checks. So, why does the laptop not switch on? For a MacBook logic board to switch on, the first two things we need are two power rails. We need PP Bus G3 Hot, the infamous power rail. That's the main power rail in a MacBook that on MacBook Airs should be at around 8.6 volts if my memory serves me. And we also need PP3V42, which is a 3.42 volt power rail. Now we should have PP3V42 because that powers the light on the charger. So by virtue of the fact that we have a light on the charger, that means we have that power rail already. So let's see if we can find PP Bus G3 Hot and see what's going on with that. Now it's fairly easy to find. This big inductor here, that is the output for PP Bus G3 Hot. So I'm going to stick a black probe on ground and we'll measure the power there. And we've got 638 millivolts, so half a volt basically. So yeah, that guy should be at like 8.5 volts or thereabouts. So that is our problem. We're missing the main power rail in this laptop. Fine. Okay, so let's see if we can figure out why that's not there. There is some power there. You know, we've got that, you know, half a volt. It's not just gone entirely. So I want to know, is that shorted? So I'm going to unplug the power now. I'm going to go over to resistance mode. We're just going to check what the resistance to ground is. So, again, black probe on ground. Okay, yeah, like half an ohm. There's your problem. So we have a short on PP Bus G3 Hot. Not actually very common. I don't do lots and lots of MacBook repair these days. However, I don't actually see a short on PP Bus G3 Hot very often. But there we go, that's our issue. So there is a short circuit there and it's dragging the rail down. The power source, PP Bus G3 Hot, is producing power, but it's going straight into a short circuit, which is pulling the voltage down to ground. Because remember, voltage is a potential difference. And if the difference between positive and negative is 0, because they're connected together, then you have no voltage. So that's what's going on here. So we need to find out where that short circuit is. So what could be causing our issue here? I'm going to quickly check. I'm going to quickly check the backlight. I don't know if I can find out actually from here if the backlight is causing the issue. I think the backlight is sufficiently isolated that if I check the output for it and find a short circuit there, that's probably our issue. I'm going to do a curiosity check. Let's just go beat mode. And black probe on ground. And I'm just going to check the diode over here. This is the output diode to the backlight. That's not shorted to ground. So the backlight, which is an absolute classic to get shorted to ground, isn't our problem. Very well. Is the backlight fuse gone? Nope. Backlight fuse is intact. So, however, the backlight fuse, we go PP Bus G3 Hot into the backlight fuse, then into this chip here. And that chip down there in the bottom right, I'm not going to bother giving you close-ups because this isn't the problem. That chip there is then a MOSFET which switches the backlight on and off and stuff like that. So that isolates the backlight circuit. At any rate, that's not our issue. All right, so where else could we be shorted? Well, a lot of places. PP Bus G3 Hot is the main power rail in this laptop. It powers everything. So what we're going to do is we're going to take the logic board out and we're going to do a full inspection both sides and see if we can see anything obviously wrong with it. There's nothing visually wrong on the top, but we don't know what's underneath. Let's take this thing apart. This thing's really clean underneath. Not seeing any signs of liquid damage or anything like that. It's probably just where it got sat on and bent the logic board. No visual problems. It looks like we're probably going to need to go straight to power injection on this. Yeah, I think I'm going to go straight to voltage injection, because there's no visual issues on the board. So yeah, we have a short circuit somewhere on this board. I have no idea where, so we're going to inject power and we're going to see if that short circuit heats up. So I've got 2 jumper wires here and we're going to solder them on. Right, so I'm going to solder onto the output side of the PP Bus G3 Hot fuse. Actually, I should actually remove this fuse first and just check that the short circuit is not in the PP Bus G3 Hot circuit itself. I'm going to quickly do that. There we go. So just to confirm, our short circuit is almost certainly going to be on the system side. Yeah, there's our ½ ohm short. And the PP Bus source side. There we go. That's now going up into the kilo ohms. Cool. Okay, jumper wires on. No, I did these in the wrong order. Have we got a better ground pad than that screw hole? Probably. I'll use a screw hole. Screw holes are really easy to clean up afterwards, which is why I tend to put my ground wires on screw holes. You could jump onto the back of a capacitor or something like that. However, screw holes, you're not going to damage a screw hole. So, all right. We now have 2 jumper wires with a short circuit between them, which I shall just confirm on the multimeter again. And the reason why I keep confirming stuff like this is now and then you'll get something wrong and you'll put your jumper wires in place and then the short will be gone and you'll be like, oh, what the hell? Whoop. There we go. ½ ohm. So now I will set my power supply up to 1 volt and we're going to go, I'm going to start on 3 amps. We'll probably need more than that, but I always start on 3 just in case. And we're going to connect the power supply up to our jumper wires. Like that. And when I turn the power supply on, as you can see, we've gone down to 0.8 volts and 3 amps. So remember, the voltage has dropped because the potential difference between our positive and negative is very low because they're shorted together. So when you inject power, the voltage will dip. That's normal. We've gone up to our current limit of 3 amps. So whatever is shorted in the board is now absorbing that 3 amps of current and converting it into heat. So we need to find that heat. So, is anything heating up? This is the point where I should pull out my thermal camera, but I still haven't bought one. I do plan to, so all the people who are going to furiously write in the comments, thermal camera, yeah, I know. I'll get one at some point. In the meantime, I'm going to do the old-fashioned touchy-feely method. I'm going to see if I can find anything hot with my hands. The board is still a little bit warm where I used the hot air on it earlier on. I should have waited a bit for it to go cold. It's like divination, this. It's not a very efficient method. However, it's a lot cheaper than a thermal camera. Right, I'm not feeling anything yet. I might just jump straight up to 4 amps. I think I'm going to. Okay, we've topped out at 1 volts now. We're at 1 volt, 3.7 amps. So I'll have to increase the voltage if I want to pump in any more power. Because we have half an ohm of resistance, the voltage will start building up because there is some resistance. So I'm actually going to step that up to 2 volts. There we go. We're at 105. We've now dropped to 1.05 volts, 4 amps. So who's tanking 4 amps of current? Might have to take the CPU heatsink off. Check if there's any of the V-core. Something in this area. I found it. It's you. There we go. And you can actually see a tiny black mark on that capacitor there. That's our guy. So let's take that off the board and our short circuit should disappear. And then what we need to do then is, because this is a MacBook logic board, I've got schematics for these so I can look up the value of that capacitor. Or we can also remove, as you can see, there's 4 other capacitors next to it that are identical. So we could either look up the schematics or we could remove the other one that's next to it, check the value of it, and then we'll know what we need to replace it with. There we go. Okay, so firstly, there's our half ohm short. And secondly, we should now find that our logic board is no longer shorted. So we'll just check ground to PP bus G3 hot. There we go. And we've now got a kilo ohm and rising, or approaching the kilo ohm. Hundreds of ohms, not half an ohm. Good. So because I do have schematics for this, let's find out what the hell that is. What's it around? It's around these secondary power systems. No idea what that is. Let's find out. This board it's an 820-00165. Right, here is our board view. And it was that guy there. So that's C7434, which is apparently PBus _ S5 HS Computing iSense. So this rail here, this is an S5 rail. So this is an always on rail, like PPBus G3 Hot. It connects directly to it. And you can see already here, this goes over to the left-hand side. And if we zoom in over here, these are the CPU VRMs over here. So this guy is this is the first input stage for CPU V-core. So yeah, I'll open up the schematic since I've got it, just so we can find out exactly what that is, just for good measure. Oh, I lie. Okay, yeah, it's not an input stage for CPU V-core. It's the input for the memory V-core. So if you look at this here, firstly, in the bottom right of the page, it says LPDDR3 supply. So that is that's low power DDR3 power supply. And if we look over here, we've got a buck regulator. So we've got a pair of MOSFETs, a coil, output capacitors. And the output for that is PP1V2_S3. And that goes to the RAM and powers the RAM. So that's what's going on there. However, it's powered from PPBus S5 HS Computing iSense, and that's the same rail that powers CPU vCore, and that rail in turn comes off of PPBus G3 Hot. So yeah, this is to do with the memory power supply. Interesting. Cool. Right, well, we can also see from here that this is a 62 microfarad 11 volt polytantalum capacitor. So I'm going to go get my breaker boards and see if I've got a spare one of these. Be right back. Okay, right. I have a breaker board here, and these capacitors here are also 62 microfarad 11 volts, which I know from past experience, and also because I have the schematic for this board, so I can look it up. If you don't have one of these capacitors or spare boards like this lying around, then you've got to jump on eBay or AliExpress or Mouser or your website of choice and get one. Right, and let's just make sure that this guy is in spec because it is an old capacitor. Oh, damn it. I should have used my tester. This is why I used the tester, but I wanted to do it with the multimeter because that's what other people will have. There we go, 68 microfarads. That's good enough. It's a little bit over. However, over is good. With capacitors have got like 20% tolerance on them. So it's entirely normal to see them look, well, yeah, it's pretty uncommon to see them bang on the mark, to be honest. So yeah, that is absolutely fine. So I'll tidy up these pads now, and we'll solder that in place on our board. Oh, let's air now. There we go. And let's remove the jumper wires while we're here. There we go, like I bought one. And I'm just going to do one more final short check just to make sure I have not done any colossal goof ups. Yeah. Killer ohms of resistance. Excellent. So when I plug this all in now, we should find it works. Okay, right, and plug it in. Green light, and there's a spinning fan. Spin. Anything on the screen? Oh, there's a chime. That's a good noise. We don't have an SSD fitted. However, it should pop up with the question mark folder in a minute to say no boot device. But yeah, I want to see that, and I want to see that the backlight works. Yeah, there we go. Good. Okay, that is enough that I'm going to reassemble the rest of the laptop. So power off. Let's get all the screws in, and we are donezo. We are done like Sunday dinner. There we go, we're all done. Thanks for watching, everyone. That was a good fix, I'm happy with that one. Very routine voltage injection, find the short circuit, find the dead capacitor and replace it job. So yeah, this is very much entry-level logic board repair stuff. So this was one of the easy ones. But I'm kind of glad because it was a very textbook example as well. So if you're looking to get into board repair, these are the kind of problems that you want to get on your bench, because these are the kind of ones where you actually have half a chance of being able to fix it while not being an absolute master of this, which I'm absolutely not. In any case, thank you very much for watching, everyone. My support links are in the description down below for my Discord, my Patreon, and my Twitter, or hang around for the end card, and I'll see you in the next video. Bye!